Okie dokie. So graphing absolute value is very similar to graphing a line. And I've already kind of illustrated what that graph is going to look like. It's going to look like a V, but I'm going to graph it for you. So I'll show you that it's very similar to graphing a line. And the absolute value has the absolute value bars. So you're going to start at 0, 0. And then the parent function of a line has a slope of 1, and you go up and you put a bunch of points because it's a slope of 1. And then you connect the dots. And that would be the start of a line. But the shape of absolute value is very similar. It starts out the same, but we're going to make the pattern create a V. So I'm going to mirror that image right over here. So as soon as you create the right half of your graph, you will make a mirror image, but creating a V. Please make sure you put arrows on your graph. So what letter did I say that this graph looks like? The letter V. Okay, the letter V. A parabola kind of looks like the letter U, and an absolute value looks like the letter V. There is a vertex point. The vertex point is always going to be H, K, and the axis of symmetry is X is equal to H. So this is the parent function of an absolute value with no transformations. So this is the parent function, no transformations. It's not shifted up, down, left, right, stretched, compressed, reflected. That is the parent function of an absolute value. But I'm not going to ever ask you to graph the parent function. We're going to get a little bit more exotic with it. So let's write down how the transformations work. So when you don't just have y is equal to x, there's these placeholders for a, h, and k, and those are where the transformations live. So a will move the graph a certain way, h will move the graph a certain way, k will move the graph a certain way. So a actually has two types of transformations. And so I'm going to draw a line in this box. So I'm going to draw a line right here. Because A has two types of transformations. And so the first transformation we're going to talk about is when the number in front of the absolute value, this value here, if it's a negative. Nathaniel, whenever the value in front of the absolute value is a negative number, it's going to create the graph to reflect over the x-axis. And so we've got when A is positive. So when you have a positive A, your graph is going to open up. And then when you have a negative A, the graph is going to open down. And so another way to think of that is that when it's positive, it opens towards positive numbers. Positive numbers are up. And when it's negative, it opens down and it opens towards negative numbers. And so I'm going to show you. So this says explain in words, and then this says kind of sketch an illustration. So when we have a positive A, the graph is going to be a V and it's going to face up. When you have a negative A, it will reflect over X. So a negative A reflects over X. And it looks more like a mountain. You reflect over X and you're negative. When you point up, you're positive. When you point down, you're negative. And so that happens anytime there's a negative right here. Let's also write again up at the top, the vertex is HK. So that's very important. The more times we write this, the more likely we are to remember it. Okay, A also can move your graph by making it stretched. So when it's stretched, your graph is going to look skinnier. And when it's compressed, your graph's going to look wider. So this happens that you can stretch and your graph looks skinnier. Or you could compress and the graph is going to appear wider. Another way to think of this, the A value is that's the slope for your line. So the A value is the slope for the line. So the beginning of your graph. So this is like slope or rate of change. Okay, it's like slope or rate of change. And so when this value is greater than 1, you're going to have a skinny graph. When the value is a fraction between 0 and 1, so when A, and the way that we can write that is like this. Greater than 0, but less than 1, your graph will look wider. So you're skinnier when it's a whole number, a number bigger than 1, and you're wider when it's a number between 0 and 1. But you can think of it like slope. Now we're going to talk about H. H is part of my vertex. It's the X part of my vertex. And so the X-axis is left and right. So the H moves me left and right. But one thing about H is that it moves opposite. Thank you. So I'm going to show you what it looks like inside the parentheses. So when you see inside the parentheses X and then it's a minus H, it's actually going to move you right. And when you see X plus H, it's actually going to move you left. So when it's in the parentheses and you see a minus, it moves you right. It doesn't feel intuitive. It is opposite. When you see a plus, it's going to move you left. So I'm going to show you what that looks like on a graph. So I'm just going to make an X and a Y and show you those graphs. So when you have X minus H, you're going to move over to the right. Ooh. You go right. And when you have X plus H, you're going to move left. Okay, so H, it goes with X and it moves you left and right, but it moves you opposite. So minus goes right, plus goes left. Okay, it's what you see at the very end. And it's also the second part of your coordinate. It goes with Y. It's the Y part of your vertex. It moves you up and down exactly the way you would think. When it's positive, it goes up, and when it's negative, it goes down. So this is the only thing that's opposite is with in the parentheses with X. X is opposite. So when you see a positive K, you move up, and a negative K will move you down. So I'm going to show you that. Let's graph that. So this would be a positive K. And this would be a negative K. So K moves exactly the way you think. The only thing that's opposite is the H. H is opposite. Is anybody still copying? Okay. Here is the formula again. I wrote it here, even though you have it at kind of towards the top of your page. I wrote it so that we can refer to it. The first types of problems that you have on your homework. So this is like questions 5 and 6. Question 5 and 6, you're writing equations from some verbal explanation. So we've got some word sentences that we're going to make a math sentence or a math equation with. And so it says that we've got the absolute value function, and we're going to stretch it vertically by 3 halves, and then we're going to shift it left 1 and up 3. Anytime we have these types of problems, I am going to write the equation, and I'm going to leave myself space in the 3 spaces that you could have a value, A, H, and K. There's only 3 places you can plug in a value of or put something there. So I'm going to write my basic function. It can be y or f of x. It doesn't really matter. Y equals, I leave myself a little space after the equal sign. Absolute value x. I leave myself a little bit of space. So I'm leaving myself spaces right here. A little bit of space, and then I've got space that I could write after. I'm going to do the same thing for question 2. Y equals, leave myself a little bit of space. So there's 3 spots. This is a stretch or compression or reflection. Let me write these down. So this is a reflection, or it is a stretch or compress. The H moves me left or right. And the K moves me up or down. So I have A, H, and K. So let's read through this sentence. I am stretched by 3 halves. Does that go before, in the middle, like first, second, or third? Where does that go? First. Okay, it goes where the A goes. So I'm going to put 3 halves right there. Left 1. Does it go first, second, or third? Okay, it's an H movement. And since it shifts left 1, I have to put plus 1. It's going to be opposite. Okay, to move me left, I have to have a plus. And then what about up 3? Is that an A, an H, or a K? Okay, and it's exactly the way we think it's going to be. There's my equation. For the next one, a reflection, is that an A, H, or K? A. So to reflect it, I need to have a negative. Right 3, is that A, H, or K? H. And to move it right, I need to have a negative. I need to have it opposite. And then down 2, is that A, H, or K? K. Down, what do I need to put to say down 2? Negative 2. That is how you're going to do questions 5 and 6 on your homework. we are going to start graphing. So when we start graphing these, we need to know the vertex and we need to know a slope and we need to know if it reflects. So we pretty much need to look at the equation, look at the A, H, and the K. But our first step is always to identify the vertex. The vertex is going to be HK. And it will always be opposite H and then K for my vertex. So here, I'm going to put opposite -2. So it's going to be +2, 4. And a vertex always has parentheses. Is there anything for A? No. So that means that it's a standard slope of 1. To find the vertex, this means that I'm going to go left 2 and up 4. If you want to write down those transformations, you can. I'm going to go left 2, up 4, and I'm going to put my vertex point. Left 2, up 4. So there's my first coordinate. That's where I start my graph. I always start at the vertex and then apply the slope or reflections. There isn't a reflection, so I'm just going to apply the slope. So that means up 1 over 1. As soon as I create my graph this way, I can continue the pattern, but instead of continuing like a line, I'm going to make it a V. So going out the other direction, I will create the other half of my absolute value. Absolute value, like the V in the name, will always make a V. Hmm? What do you mean to the right? Yes. Yes. Why didn't y'all stop me before now? Why did I go negative? I don't know. I don't know either. It's 2, 4. We go 2 and then up 4. Sorry, guys. That's why we use pencils. Yeah. Thank you, Jaden. We go up 1, right 1 to create our line, our first line. Hello. Okay. Camilla? There's a special envelope. That's what he said. Now then, my graph is looking like it's in the right space. Thank you, Jaden. Okay, to reach out if you think that I have made a mistake. I am very smart, but I am human. I do make mistakes, and I'm not ashamed of it. It's okay. We all make mistakes. All right, question number 4. Let's keep going. I need to identify my vertex, and it looks like that I have a different slope this time. So I know that my vertex is H and K. H is always with X, and then K comes after. Ooh, I don't see anything right here. What do you think it is? 0. So it's the same thing as +0. So my vertex, what is my vertex? -3, 0. Very good. It's opposite H, K. For this one, I do have a slope other than 1. So what is my slope for this one? 1/2. That is a value less than 1. So it's actually going to appear that my graph has been compressed. And to plot my vertex point, I'm going to go left 3, and then I don't go up or down any. So I'm going to plot my vertex correctly this time. I go -3 and I don't go up any. So my vertex, -3, 0. This time when I apply the slope, I'm going to go up 1 and over 2, up 1 and over 2, up 1. And remember, you always go to the right. Your directions say that you have to plot at least 5 points. I typically plot as many as I can plot before I run out of graph. So as soon as I have created my graph to the right, I'm ready to create my graph to the left. And what shape does absolute value graphs make? A V. Okay, I'm going to go up 1 over 2, up 1 over 2. So do you see how this one is wider than this one? Yeah, that slope kind of squishes it down. Let's do some more. Example 5. Remember, I've got to identify my slope, my h, my k. So my h is always with x, and then my k is after. What is the vertex for this one? There's no number with the x. So what should it be?
0.
0. So my vertex is going to be 0, and then what? -4. Very good. My slope is different. What's my slope this time? 3 over 2. Don't be confused. When the number is bigger on top, it's actually a number bigger than 1. So this is going to create a graph that's a little bit more skinny. To create or to plot my vertex, I'm going to go down 4. So for this one, I go down 4, I plot my point, and then now I'm going to apply the slope. So I'm going to go up 3 over 2 to put my point, and I'm going to do that a couple more times to the right. And I can connect the dots. As soon as I make my graph to the right first, I can make my graph to the left. What shape does absolute value make? A V. So I'm going to continue the pattern to the left. There we have it. My next problem. I need to identify the vertex, but the first thing that I see is a negative right out front. What is that going to make my graph do?
Go down.
Yeah, it's going to reflect. Please forget that. So I'm going to give myself a little reminder. This graph is going to point down. I don't want to forget. All right, I need to identify H and K. H and then K. What is my vertex going to be? -2, 0. There's nothing written in the K spot. It is a 0. My transformations, I am going to reflect. Or specifically over X, I'm going to reflect over X. Or another way you could say that is that the graph is negative. And to plot my vertex point, I'm going to have to go left 2. So I'm going to go left 2, and I'm going to plot my vertex point. It's at -2, 0. And then I'm going to apply this slope. Oh, what's the slope for this one? I didn't even write it down. My slope for this one is -1 over, I almost put 2. I was just listening. So -1 over 1. So from my vertex point, I go down 1, right 1. I'm going to continue the pattern to the left, making what shape? A V. On your assignment, the first 4 questions are graphing, so you can do the same thing we just did on these 4 examples. The next 2 questions are the sentences that you have to write an equation. On the back, you have a graph and you're making an equation. So to be able to do that, you're just working backwards. You need to identify the vertex. You need to identify the slope. You need to identify if it's reflected. And if you know the vertex and you know the slope, you can write an equation. It's just like the sentences. So I don't do an example with you like that because I believe you can do it. So you're going to work you have questions 1 through 10 that you can get started on. In fact, you can do through question 14 if you want to, but I'm going to give you some homework time to get started. And then we will do the next 2 questions from the notes. We'll do those after our homework time. So let's take a break and do some homework time. I'm going to give you 15 minutes of homework time. Yeah.
Is this
It's going to be opposite. So opposite, and then that one stays the same. Good job. So we've got question 7 and question 8. We actually did a little bit of this last class. It was like the first 4 problems where I'm giving you an X value or I'm giving you a value that you plug into absolute value and you evaluate. So let's do this. The first one says the function is equal to the absolute value of X minus 2 plus 4. Well, it wants you to find f of 1. That means that X equals 1. So we're going to plug in X equals 1. So when we rewrite this problem, I'm going to write it as 1 minus 2 plus 4. And I'm going to evaluate very slowly. What's 1 minus 2? Negative 1. What's the absolute value of negative 1? 1. What's 1 plus 4? Okay, so what we're figuring out, f of 1 equals 5. What'd I do that for? Don't write that down. F of 1 equals 5. And this actually makes a coordinate where this is the X value. And then let me label those. This is the X value and this is the Y value. And so this creates a coordinate 1, 5. So this is the actual answer, this right here. But this creates this coordinate 1, 5. And so it says that I could check my coordinate to make sure it's correct. On questions, on graphs 3 and 4. So I'm going to go back in our notes. Graph 3 and 4. It said that it has the point 1, 5 on it. So 1, 5. So I'm going to plot this point. So this was from question number 7. So if I go to my graph it says when X is equal to 1, f of 1 should equal 5. So I go up to 5. Yes, it does. It's on my graph. So this point right here, that represents this point right here. If I plugged it in algebraically, if I plug in 1, I get 5 as my answer. So that's what the last few questions are asking. So we can go back and do the next one. This one, we're finding, and this one goes with question 4. F of negative 5, we want to find that. So guess what? I can already go look on my graph and I should know what the answer is going to be. This says X is equal to 5. That's the problem that I'm doing. This is when X is equal to negative 5. So I'm going to go back to question number 4. At -5, I go over to -5. My answer should be 1. If I do this correctly, my answer is going to be 1. I know because I just checked it on the graph. So I'm going to come back here. Let's do the actual algebra to back it up. So if x is equal to -5, I have 1/2 absolute value, and I'm plugging in -5 plus 3. What's -5 plus 3? -2. What's the absolute value of -2? 2. So this is going to be multiplying, and it's 2. Is 2 the same thing as 2 over 1? If I'm multiplying fractions, I would rather multiply 2 fractions because I multiply straight across. So this turns into 2 over 2. What's anything over itself? 1. So this is f of -5. This is my answer. And this represents my x value and my y value. So I have this coordinate -5, 1, and I already discovered that that is on my graph. I could go back to my graph and I could plot that point, or I could identify it. So number 8, that coordinate -5, 1 actually lives on my graph. I just checked it. So when you were coming and you were looking at questions 1 through 4, that's why I have little notes on there, because questions 11 through 14 show up on graphs 1 through 4. So I'll go back to this part and we are done.